The PSVM project is a 4-field development in ultra-deep water off the coast of Angola. The fields lie over 300 kilometres from Luanda in Licence Block 31. On the surface is an FPSO, a floating production, storage and offloading vessel, and it's connected to a subsea production, injection and export system by a series of risers. What makes this project particularly challenging is that it's located in 2 kilometres of water. It takes a remotely operated vehicle, or ROV, around 2 hours to make a journey that's taking us only 10 seconds. As well as the water depth, there are great distances between the 4 fields, spanning an area 17 by 31 kilometres, making it one of the largest single subsea installations ever. In the south of the development area is the Plutão field, which will produce resources from 3 separate reservoirs. What's here is similar to the other fields because the PSVM project has adopted a standardised design for the subsea infrastructure. "15 kilometres away and working independently from Plutão is the Saturno field, which will produce from 2 target reservoirs. A further 10.5 kilometres away is the Venus field, which will produce resources from 3 separate reservoirs. And 13 kilometres further on at the northern extremity of the development is Marte, which will produce from 2 target reservoirs. The Marte and Venus fields share the same infrastructure, as this helps with fluid flow. The subsea system is made up of 3 similar but separate networks: Plutão, Saturno and the linked Venus-Marte. Each of them has an independent production, water and gas injection and service and utilities system. The production system transports fluids to the FPSO. The water injection system is used to provide pressure support into the reservoirs. The gas injection system, which also provides pressure support, is connected to Plutão and Saturno only. The service line is used to flush and clean the production system as required. Electrical power, hydraulics and a range of different chemicals are delivered to each field by dedicated umbilicals. As each of the 4 fields operate in a similar way, we'll look in more detail at just one, Plutão. The producer wells are deviated and use open-hole gravel pack completions. This type of completion was selected to manage sand production. The longest well goes nearly 3 kilometres below the sea floor. Each of the wells is designed to target an area of 50 by 50 metres in the reservoir to maximise their effectiveness. Reservoir fluids are produced back to the production tree and from there onto the production manifold. Each of the manifolds contains a multi-phase flow meter that provides continuous information to update the reservoir model. This makes it possible to help optimise resource recovery and improve reservoir management. Fluids now pass through flow line termination assemblies, known as FTAs, and then into the production flow lines. There is a total of 50 kilometres of production flow lines on the seabed. The production flow lines are pipe-in-pipe construction to maintain fluid temperatures. In between each of the pipes are layers of insulation to minimise the effects of cooling from the seawater. Fluids continue to the end of the flow line, then into another FTA, and then to the surface through a single-leg hybrid riser, or SLHR. The risers are held in constant tension by driven piles, with ballast at the bottom and buoyancy tanks at the top. The last 300 metres to the surface are flexible risers, made flexible to allow for the motion of the current and tides. They carry the fluids into an externally bow-mounted turret on the FPSO. The produced fluids now pass into a two-stage separation process, where the water and gas are removed from the oil for further processing. The processed oil is stored in cargo tanks until it is tandem offloaded every 6 to 7 days to a trading tanker. The FPSO has storage capacity for around 1.8 million barrels of oil. The produced water that was removed from the oil is cleaned, then mixed with seawater, which has passed through a sulfate reduction plant. The produced gas removed from the oil is cleaned and compressed. The water and gas then travel through the turret before going subsea to be re-injected into the reservoir to maintain pressure support, the opposite journey to the produced fluids. Excess gas is routed via an export pipeline to a gas gathering network for onward transport to the onshore Angola LNG facility. The injection gas, along with the water, returns to the reservoir. This maintains production. For the operation of the subsea system, there are 95 kilometres of umbilicals, with a dedicated umbilical to each of the 4 fields. There are 6 different umbilical types, with different numbers and combinations of cables and tubes inside. Inside the main umbilical, there are 10 power and signal cables, and 15 tubes for delivery of hydraulic fluids and the various chemicals required to operate the subsea system. Within the dynamic section of the umbilical, there are also carbon fibre inserts. These increase its strength to allow for movement of the FPSO. Back on the surface, while the FPSO's turret is fixed to the seabed, the vessel herself is free to weather vane around it, so she can face into winds and weather and give the smoothest ride for those on board. The power generation on board is provided by 4 gas turbine generators with enough capacity to generate 100 megawatts. The accommodation has capacity to house 120 operations personnel, plus a further 20 in pull-down bunks. Holding the turret in place are 12 polyester and chain mooring lines. Fixing them in place on the seabed are suction piles. To look in more detail at the other subsea structures, the base of the vertical riser components is held in place by driven piles and ballast. The tops of the buoyancy tanks are held 100 metres from the surface. The tanks generate over 600 tonnes of lift to support the weight of the rigid riser pipe beneath. The manifolds are supported off the seabed by the manifold support structure, which is held in position by a suction pile. The FTAs and ITAs are supported by mud mats. First oil from PSVM is anticipated during the second half of 2011, and production is expected to continue for the next 20 years, making it an important project for both the partner group and Angola.